Okay, just a short story up front. I often share my biases with students, and sometimes when I'm being observed as a teacher, the other teachers say, "Oh, you shouldn't share your biases with your students." And the reason I share a bias is that I have a bias against graphing a system of linear equations. The main reason, if it's not an easy solution, I'm going to have a tough time picking it off. It's so true. I'll have a tough time picking it off. So what I claim over here is that if you have graph paper and a ruler and you're pretty careful, you still may not be able to get the point of intersection, because if it's not clear, you're going to have a tough time getting it. So what I want to do is talk about this particular problem, but I want to go to the graph, right? It's going to be figure 29 now. And this is figure 29. Now, when I'm doing the graph over here, I want to point out you still got to get, easy points on it. Now, when I say easy points, you may even disagree about what easy is. But if I were like maybe doing this equation over here and someone said, gee, I wonder what points you choose for that. Well, I'll be honest with you, one point I choose would be 0 for x. And then you would get, let's see, if I chose 0 to be x, you'd get minus 22 over 4, which is minus 11 halves. All right? And then someone says, would you pick another easy point? I think I would, because I need 2 points to graph a line. And what's the other point going to be? Well, I'm going to choose y to be 0 now. And what would you give here? 22 thirds. And I want to plot those points. And I got to plot 1 point at a time. And let's do that in red now. So 0 minus 11 halves. Well, minus 11 halves, it's not that bad. It's minus 5.5 down. And the other point, 22 thirds, it's 7 1/3. All right, so I'm going to say over here somewhere. And then I get my ruler out, and I'd graph a line through those 2 points. Okay? I got to do the other one too. Now let's do that now. The other one is this one here. And I want to see if I can do that. So I'm going to pick x to be 0. And then you can get minus 25 over 14. And then I'm going to choose the y to be 0. And you can get minus 25 over 9. All right, let's do the minus 25 over 9 first. Let's see. Minus 25 over 9 would be minus 2 7/9. So I'm going to say somewhere about over here. And let's do minus 25 14ths now. That's going to go in minus 1. And let's see what you get. Let's see, 6 and 5 is 9 14ths. So that's about over here somewhere. Then what I do, I take my little ruler and I draw a line through that. Get rid of the ruler. And I think I'm looking at a point of intersection. Here comes the problem. I'm looking up and I'm looking over, and to me, it is clear as day that they're definitely not integers if my graph is accurate. The problem now becomes I wonder what those numbers are. By the way, it doesn't look like 2.5, but I was hoping for 2.5. The next number I would look at for this one over here, I'm going to say it looks like 2 2/3. By the way, I'm not saying it's right. I'm just saying it looks that way. And then this one over here, I'm going to be honest with you, I really don't know, but I'm not going to say it looks almost like it's halfway, but not exactly. Let me point this out. Do you see how big that blob is there? That blob could be anywhere. You get the idea? There's a big band of numbers over there. But I'm going to say, you know what? Maybe it's minus 3 1/2. Now, granted, I realize what some people are saying. That's wishful thinking that they're simple. And you're not kidding, it's wishful thinking. What I need to do, though, is determine if it's correct. I don't know if it's correct. I have no idea. So what I'm going to do is I'm going to say the point of intersection. The point of intersection in my wishful little mind is going to be, let's see, I'll write it as improper fraction because it's easier for me to deal with. It's 8/3. Let me check, I did it right. 3 times 2 is 6, 7 8/3. And then it's going to be what? 6 7/2. Minus 7/2, I'm sorry. I just like to use that in that form. And I'm going to check it now. Check. And I'm checking it here. So what do you get? Let's see, 3 goes into 9 3 times, so 24. Let's see, minus 2 goes into 14 7 times, and 7 times 7 is 49. Does that equal minus 25? Yeah, perfect. That's good. Let's do the next one. Don't think it's right yet. 3 times 8/3 is 8. And then I'm going to get plus 14. Does that equal 22 as advertised? Yes. This is the point of intersection. Thank you.